Okay, now we're recording. We're all too quiet today. No one's keeping me on top of things. So we're going to put this in SATA port on the motherboard 2. And our second computer. And we're going to connect our SATA cable to our second drive. All right. Now we need to provide power for these drives. So we click on our power supply, and we have our SATA cables. They're 15 pin. And just choose one for the top drive and another one for the bottom drive. So we connected our SATA cables. We plugged in the correct power. Now we want an eSATA port. So let's go back to our motherboard. We have one slot open here, one E slot open. So we go to our eSATA, our port connectors. There's an eSATA drive. And go ahead and plug that into this. And you see that essentially it goes there, and it does have a SATA cable. And we want to connect that to the motherboard, and that's here. So we're just going to choose that third port that's open. All right. So now we have both hard drives in with power and our eSATA drive in. So let's go ahead and boot the computer. Turn them on. And we don't really see anything because there's not an OS. So we do want to go into our BIOS, and this will happen often. Basically, you'll get just a idle boot screen because there's no operating system. Don't panic. And this is just saying that although we have drives in here, we don't have an OS. So there's nothing really to boot to. So the only thing that you can access will be that BIOS, the BIOS system information screen. And hopefully you remember this screen. So basically you can either go into the main screen and scroll down. It will show you that it has two SATA internal devices, SATA 172 and 800 gig hard drives, and everything else about the system that's configured. We can't do that. Also, you can actually take a look at, although you don't have to worry about the drivers. All right, so that's checking to make sure the drives are detected in the BIOS. Any questions about this lab? So let's go ahead and score it. Okay, you did good. All right. Okay, we're going to go right into another lab. Let me see what's the next video. Oh, well, we're going to watch another video first before we do the next lab. And this is going to talk about RAID. And that's not the bug spray. It's kind of a disk configuration. That is very important. So I would definitely recommend, there's a study sheet on the 542. Make sure that you take a look at that. It talks about disk configuration, and you did a really good definition of what RAID, R-A-I-D, is as far as storage devices. So here we go. All right. another very, very good video. So.
In this lesson, we're going to talk about a RAID array. RAID stands for Redundant Array of Independent Disks. RAID originally stood for Redundant Array of Inexpensive Disks, so you may hear that definition sometimes. So to understand how a RAID array works, you need to understand 4 critical RAID concepts. Let's start with striping. When we implement striping in a RAID array, what we do is take data that's being written to the hard disk drive and split it into 2 so that it's written to 2 different hard drives at the same time. Here is our RAID array that contains 2 hard disk drives. Let's say we have a chunk of data right here. It's coming down from the operating system and it needs to be written to the disks. With striping, we actually split that data up into chunks and we write some of that data onto this hard drive and we write the other part of that data over onto this hard drive. You have this piece of the data and this piece of the data over here. On this hard drive, you have this piece of the data and this piece of the data saved. The data is saved to the hard drives at the same time. Now, even though we have 2 hard disk drives in the striped array, the operating system sees these 2 drives as one logical hard disk drive. It does not differentiate between the 2. So, the key benefit to striping is speed. It all goes back to the old axiom that says, many hands make light work. If you have to dig a hole and you're digging it by yourself, it takes a long time. If you have 2 people digging the same hole, it takes half the time. The same principle holds true when writing data to the hard drive. If we can have 2 heads on 2 different hard drives writing the data split in half, then we can write data, theoretically, 2 times as fast. In actuality, it's not quite 2 times as fast, but it's close. Striping can dramatically increase the speed of your disk I/O operations. Speed is also a factor when reading data. Instead of having to read all of that data off of one hard disk drive, we can read that data off of 2 hard disk drives at the same time and put the chunks back together to create the information. Striping is really good in RAID array, but there's one problem with it. If you look over here, notice that we have some of the file on one hard drive and some of the file on a different hard disk drive. What would happen over here if this hard drive fails in this array? If one of our hard disk drives fails, then we lose half of every piece of data that's written to it. In this case, the data becomes corrupt, and that's a problem. Using striping alone in a RAID array does not increase fault tolerance on your system. In fact, it decreases fault tolerance on the system, and that's because you have multiple points of failure. Therefore, RAID includes a couple of other concepts to help protect the data, not just to speed things up, which striping does, but to actually make data redundant. The first of these is mirroring. With mirroring, you set up a 2-drive mirrored array. It looks a lot like the striped array that we saw up above. You have 2 hard disk drives and they're connected together in an array. Now, just like with a striped array, the operating system sees these 2 drives as one logical hard disk drive in a mirrored array. For example, if we're setting up a hardware RAID array, these 2 disks together might be C:\/ on the Windows Server system. In a mirrored array, if we have a piece of information that needs to be written to the hard disk drive, we take this one piece of information here and we write a duplicate copy on both hard disk drives at the same time. It's not split up like with striping. It's a full copy written to both hard disk drives. Doing this does not increase the speed of the system at all, like striping does, but it does increase redundancy. If something bad were to happen to this hard disk drive and it were to go down, our data would still be okay because an exact copy of this data is written to this hard drive as well. In fact, most RAID systems can be configured so that if one drive in a mirrored array goes down, the other drive automatically takes over for it. So if your users are working on a file when this drive goes down, they will not notice any difference. They'll keep doing what they were doing, and the work will be saved over here on this hard disk drive. Now, mirroring is good, but there is still a single point of failure. When we set up mirroring, we use one RAID controller to control the mirrored drive array. This one RAID controller represents a single point of failure. If the RAID controller were to have an imperfection, a problem during manufacturing, or if it were to get shocked by ESD or something that caused it to fail, we'd lose all of our data. Even though it was mirrored, both hard drives would no longer be operable. In order to get around this, we can implement duplexing. Duplexing looks a lot like mirroring. We still have our two hard disk drives, but instead of connecting them to a single controller, we connect one hard drive in the mirrored array to one RAID controller, and we connect the other hard disk drive in the mirrored array to a different RAID controller. Then, when the data needs to be written, it is written to both disks at the same time, just like with mirroring, but it goes through two different RAID controller boards. The advantage to this is if this board were to go bad for some reason, our disk I/O operations would still continue. Users wouldn't notice any difference because this RAID controller would take over and continue servicing requests using this hard disk drive until you have a chance to replace this part over here. The next RAID concept that you need to understand before we move on is parity. Mirroring and duplexing work very nicely, but we don't get the speed advantage introduced by striping. Parity allows us to use striping with some degree of redundancy or fault tolerance. When we set up parity, we set up a striped array. In this example, let's say we set up a striped array between these two disks right here, and then we add a third disk to the array that contains parity information. This parity information can be used to reconstruct data if something bad happens to one of the disks in the striped array. Also, depending on the RAID level, we can use either the entire disks or part of the three disks. Now we have created a striped array that has some redundancy to it. In other words, if this disk were to go down, we can reconstruct the missing data from the parity information over here. Now let's talk about how we implement RAID itself. There are two different ways you can do it. Most of the time when you're implementing RAID, you're going to purchase a RAID controller card and install it into your system. Many servers come with a RAID controller built into the system, and you don't actually have to install a card. Others, you will have to go out and purchase a card and install it. However, that's not the only way to do it. You can also implement RAID using software. Most network operating systems support software RAID. In other words, instead of using a hardware card to manage the RAID array, we use the CPU in the operating system to create the RAID array. The software RAID works very well. It's easy to implement and it's less expensive because you don't have to go out and purchase any RAID card. However, it is slightly slower than using the hardware RAID. With hardware RAID, we have a chip on the RAID card that is dedicated to doing nothing other than managing that RAID array. If we implement software RAID, then we have to use part of our CPU time to perform RAID operations, instead of using the chip on the RAID card. Either way works, but given the choice, I would always go with hardware RAID over software RAID. With that in mind, let's talk about RAID levels. Let's start with RAID 0. RAID 0 is just simple, plain old striping. We talked about striping before, and we used this diagram. Well, RAID 0 is just that. It's striping data between two hard disk drives. While RAID 0 can dramatically increase your throughput to and from the hard disk drive, it does not provide any redundancy. If this drive over here were to die, you've lost all the data on your system because your files are split between the two hard disks. We also have a RAID level called RAID 1. Now, before we go any farther, we do need to point out that the lower the number does not mean that it is a worse or a less desirable RAID level, or that the higher the number, the better the RAID level is. The RAID number is used to distinguish how a RAID array is configured, or how the hard drives are implemented into the array. In RAID 1, we're doing mirroring. As we talked about before, if you set up mirroring, you have two hard disk drives controlled by a single RAID controller. Whenever an operation happens, the data is written to both hard drives in the exact duplicate. If one drive fails, the other drive can immediately take over and continue servicing users, providing redundancy and fault tolerance, but does not increase the speed of the system. In addition to RAID 0 and RAID 1, we can have a RAID 5 array. We may have an array that looks like this. A RAID 5 array requires a minimum of 3 disks. You can have more in the array if you want to, but you have to have a minimum of 3. In RAID 5, all 3 of the disks are striped, which dramatically increases performance, but we reserve one portion of each disk for parity information. RAID 5 works really well, however, it does have a weakness. If you do have failure in RAID 5 and one of the disks goes down, we still have parity information that can keep the array running so we can access the data, but the performance is really bad. RAID 10, also called RAID 1 plus 0, and sometimes RAID 1 and 0, is a stripe of mirrors. This means that a RAID 10 configuration requires a minimum of 4 disks and stripes data across mirrored pairs. As long as one disk in each mirrored pair is functional, data can be retrieved. However, if 2 disks in the same mirrored pair fail, all data will be lost because there's no parity in the striped sets. RAID 10 provides redundancy and performance, and it is the best option for I/O-intensive applications like database, email, web servers, or any other system requiring high disk performance. One disadvantage is that only 50% of the total raw capacity of the drives is usable due to mirroring. A non-standard definition of RAID 10 was created for the Linux MD driver. Linux RAID 10 can be implemented with as few as 2 disks, and it offers a choice of layouts. Arrays of more than 4 disks are also possible. There are many other RAID levels other than those we've talked about here, but these are the ones you should know about. In this lesson, we discussed striping, mirroring, duplexing, parity, and RAID 0, 1, 5, and 10. Implementing RAID arrays is a necessary task to maintaining and retrieving data.
All right. So who can tell me what RAID stands for? What does RAID stand for? There's 2 different answers. Anyone?
RAID stands for Redundant Array of Independent Disks.
Thank you, Nova. You get the star for today. You're paying attention. Redundant array of independent or inexpensive disks. In the old days, it was inexpensive. But server raids, things like that. All right.
Expensive disks.
Okay, so now we're going to go into our, to do 2 different RAID labs, 5.4.5 and 5.4.6. So let's go ahead and get started there. 5.4.5 is create RAID arrays. So you work at a computer repair store, you're building a new computer that will be used for video editing and storing pictures. You have installed the operating system on disk 0, that's your OS, and then install 4 SATA hard drives. You want to have the following additional volumes. Okay, you want an editing volume that's going to be labeled drive letter E, will be used to store raw video files for editing. This volume needs to be optimized for performance. And then you'll have a media volume labeled drive letter M, will be used to store digital photos and completed video files. This volume needs to provide fault tolerance so that the failure in one drive will not affect the availability of the files. So in this lab, we're going to create the editing volume as a striped volume, RAID 0, using all the space on disk 1 and disk 2. And then we're going to create a media volume as a mirrored volume, RAID 1, using all the space on disk 3 and disk 4. And we're going to format all the volumes using NTFS. All right, who knows what NTFS stands for? Before we start. Yeah, you guys have to Google faster. What does NTFS stand for? No takers. No one? NTFS. You can even type it in the chat if you want to. Are we still listening?
It's a new technology file system.
Yes, file system and file service. Thank you. Who was that? Pete?
Yeah.
All right, thank you. Okay. All right, so let's start the lab. So we're going to create 2 volumes or 2 RAIDs, RAID 0, RAID 1, using 4 drives to support this system. All right. All right, so let's go ahead and take a look at the drive bays. You see our 4 drives there. All right. All connected. Everything looks good. All right. So, let me make sure. All right, let's go ahead and start her up. Now we should have a operating system installed. Yes, Windows starts up. So the easiest way and the most effective way to get to the disk configuration utility, use your search window and type in disk, and you should see a create. Well, okay, that's not the easiest way. That's one way to go to this utility. I'm sorry. The easiest way is to right-click on the window, your magic window, and there's a disk management selection in your list of items. And that will take you to the same place, to your disk management utility. And so you see in here, we do have the 4 disks, and we're going to use all of them, so we need to make sure they're all checked. And we want to have, use the following partition style for the selected disk, the MBR, which is the master boot record, and it tells you that. But we do want to keep that, and generally, you do want to keep that in place. You hardly ever see the GBT is something completely different, and it's used differently, and it's partitioned differently. So basically, when we see this identifier pop up, we usually want to make sure they're all selected, and we hit the OK. So I just maximize, and basically when you see in this disk management, you see we have our C drive, which is our operating system drive, and we see all the parameters and specs around that. We see it's NTFS and it's healthy. It's 800 gigs with the free space of 550 gigs or so. And then we have our system. Usually the system is a portion of the C drive that you really can't touch because these are just system configurations and parameters for your OS. And usually it's reserved, and usually it's something you do not deal with. But our drives are down here in our drive area. As you see, we have our system and our C, and then we have our four drives. This 1, 2, 3, 4. Right. So the first drive, we want to use it for editing. We're going to set it at RAID 0. So what you want to do is just right-click anywhere in the drive. Just right-click, and we want to set this as a stripe drive, right? Because that's what we're asked to. Volume is a stripe volume, RAID 0. So stripe volume, and then it starts the new stripe volume wizard. These all have drive disk management wizard. And basically the wizard has to create stripe volumes in the disk. The stripe volume stores data and stripes on 2 or more disks. Remember, it's 2 or more disks. And then basically a stripe volume is really usually very fast. So you generally use it to store lots of data. So next to continue. All right, so we're going to use this stripe. We selected disk 1, but we also want to use disk 2. So 2 or more disks. So we just select disk 2 and click the add button. And so I'll do that again so that you just select the disk you need. Oops. All right. And then this is not, there we go. So this 1 and this 2. And you notice that it gives you the entire size of the disk, the megabytes. So that's in the window here. We're going to use all of the disk space from each. So we're not going to change any of the sizes. You can actually change the sizes here. But basically it's for each disk. It'll be a total of 1 tera. All right. So once we've selected that, we're not going to change any of the size. We click next. All right. So we are going to assign a drive letter as stated in our requirements. We want to change this to E. and not D. And we don't want to mount it in the following empty, we don't want to mount it in a folder. We're just going to assign a drive letter for it, and we do want to assign a drive letter. So those are your choices there. All right. And then next, so we want to format it as NTFS, new tech file system. Yes. We want to keep the default allocation size. Generally, you can change that to lower or higher, but keep the default. That'll keep the drive at its highest performance. Just remember that. We do want to give it a volume name. Remember, you do have to change that. So we want to label this one editing. That's the actual name of your volume. And generally, performing a quick format with NTFS is a good thing. It's very effective, efficient, and it takes a very short amount of time, although our simulation will be very fast, but it will take a little bit of time, a few seconds. So once we have all that information, we click next, we get our summary of all that we're doing to this drive. We're doing a stripe, this one, this two, E, NTFS, editing, quick format, yes, and then finish. And you get your warning, your dispatcher warning, which you receive on any type of RAID configuration. And basically, this is saying that you're accepting all information, and if there's anything on the drive, et cetera, it'll be converted to support this new RAID. Are you sure you want to continue? Yes. And you see that our striping matches our color coding on the bottom. We see that this light blue is stripe volume. So both of this one and this two are striped, the RAID 0, and they're now set up to be that configuration for our system. And it also shows you here, you do have the editing volume, striped, dynamic, healthy, 1.5 tera, and 100% free. They're already to store data. All right, so we want to also set up a RAID 1 on our disk 3 and 4, and this is a mirrored RAID. So once again, just right click, and it's one of the choices here. New mirrored volume, and same type of wizard will begin. Actually, it's almost exactly the same. Basically, the process is different in the back end, but the wizard looks the same. So now we selected disk 3. We want to add disk 4. We want to use the max amount for both. Excuse me, 800 gigs. So that all looks good. And now we click next. Now we want to select M. Remember M for this drive, M for RAID 1 for media. We don't want to select any of the other radio buttons. We want to format it in NTFS. We want to keep the default. We want to change the volume name to media. And we want to perform a quick format. Summary, looks good, and finish. And now we have our color coding for our mirrored drive. You notice it's both M, and this dark, it's burgundy. So that all looks very good. Our RAIDs appear to be set up. We have a nice configuration for a media / editing. All right. Any questions about setting up a RAID 0, RAID 1? It's truly that simple. If you ever want to configure your system to support, high amounts of data, you probably want to select one of these, either RAID 1 or RAID 0, or RAID 5, and we'll cover that in a little bit. All right, questions, comments? Are you still with me?
Would this be good for music?
Oh, absolutely. Absolutely.
Or video as well?
Yep. Matter of fact, this one is essentially set up for videos. Basically, it's set up to upload raw videos and edit them and then move them from E to M.
Got you. Okay.
Okay.
Would this be kind of like also a setup for a personal NAS server?
Oh, yes, absolutely. As a matter of fact, servers of that magnitude will have several of these RAIDs set up using several drives, and including virtual drives. And we're not talking about that yet, but yes, you're looking at the rudimentary method of setting up some of these high-end servers for storage. And essentially, and we won't get into this until later, most of the cloud services utilizes either a RAID 0 or RAID 1, depending, or RAID 5 or RAID 10, but we'll get into those later. Other questions? All right, so let's go and score the lab. All right, we did well. Okay, let's go on to 546. And this is actually implementing a RAID solution. So you work part-time in the computer repair store. You are in the process of configuring a new system. You'd like to install the operating system on a RAID array that provides both fault tolerance and improved performance. A RAID 5 array provides both fault tolerance and increased performance. A RAID 0 array increases performance only, while a RAID 1 provides only fault tolerance. So yes, this is, well, it really depends on what you're dealing with as far as resources. RAID 5 is usually more disk, and it's higher cost, but it does provide for both fault tolerance and increased performance. So in this lab, we want to add the minimum number of disks to the computer to create a RAID 5 array that meets the scenario requirements. Do not remove extra disks from the shelf. So we want to add the minimum, and there is a minimum number, and I'll tell you what that is if you don't know already, for RAID 5. Connect all the disks to the motherboard, connect power cables to the disk, boot the computer, and configure a RAID array in the motherboard RAID configuration utility. And this is a little tricky because the motherboard RAID utility is not completely obvious, but I've done this a few times. So I choose the RAID level based on the scenario requirements. And the scenario requirements in here is just stating we want fault tolerance and increased performance. That's the scenario requirements. And that's usually a specific array or RAID 5. And then configure the array to use all the disk space on the installed disk. So this lab is a little generic as far as an explanation. And basically, I would definitely, if I go through this lab too quickly, please review this study guide, especially focusing on RAID 5 and how that has to be configured. All right, so our computer's not on. Let's go ahead and take a look at the motherboard and specifically the drive bays. Let's see. Yep. So just to let you know, a RAID 5, the minimum number of drives in a RAID 5 is 3. You have to have at least 3 drives for a RAID 5. So we're going to go ahead, 1, 2, and 3. Right, so as we were instructed, we have to leave the other one on the shelf. We're not supposed to install it. If you install it, you fail the lab. Although you have enough cables. But, yeah. So now we want to go ahead and configure that like we would configure, like we would set up a hard drive. So let's add our SATA cables. And yeah, I like to be pretty specific processes. Just so you know, I usually do this as well. I always connect to the motherboard first, and then to the drive, just to make sure I'm covering everything. And it's a little kind of rudimentary, or at least I know I'm not going to miss anything. So I'm just connecting the SATA cables. And of course, if you, well, with this motherboard, since there was an optical device already connected to here, the SATA cables are down here. So that's why I went directly to those ports. I could see that there was a SATA cable because there's an optical device in here as well, up here. All right, so that's our SATA, our data cables for our drives. So let's go ahead and connect our power. To our hard drives. 1, 2, and that one's being used. Yeah, whenever you try to take a connector, you get the not, that means that cable's being used. And another thing too that you'll notice that we only have enough cabling in here on this motherboard and power supply for 3 drives. All right, so we have all 3 drives in, and then power and data. All right, so we connected all the drives to the motherboard, we connected power. So now we want to boot the computer, and to get to our disk configuration utility, it is in the BIOS. So before I go right to it, where do you think this utility, well, you know, we have the 3 drives in here. Where do we find this utility? Does anyone know?
Is it system configuration?
All right. And now
SATA operation.
all right, yes, go to SATA operation. That should make sense. And here we want to configure a RAID. Right now it's an AHCI, which
RAID
is
on.
normal configuration would be RAID on. Okay, so we're going to configure a RAID 5. As we stated, RAID 5 allows for performance and fault tolerance. So we click the radio button on RAID on, apply, and then exit. It should take you to the utility. And this is a little tricky. Once you get to the utility indicator, you need to hit Control-I to go into the configuration, the disk management configuration utility. Everyone get that? That was a little fast.
Yes.
Should I do it again? I can do it again. It's not a big deal. Okay, Daniel didn't get it. All right, so I'm going to exit out of this.
Yes.
Yes? Yes.
Uh-huh. We got it.
You got it? Melba says she got it. Daniel didn't get it. So basically, we're going to go back into the BIOS. Right, so you click the delete key. We go into system configuration. We go into SATA operations. You know, RAID is on. It's going to open up that utility, and we exit the BIOS and be prepared once you hit that disk control screen. Simulation is pretty slow. Then you just, it tells you right there, hit Control-I. But if you don't hit Control-I, it'll just go to that boot screen again. So here, I'll do it one more time. So this is just your boot, your no OS boot. And basically you just enter the BIOS, the system configuration. Someone's chatting. Daniel got it. Okay, good. All right. State operations, RAID on, exit, and RAID forward. Control-I. So we want to create a RAID, which is 1. You select 1 and hit enter. And we're just going to name this volume just RAID 5. You can name it whatever you want. Okay, I'll name it Ferris. And hit enter. It'll take you to the RAID level, and you have to use your arrow key, your down arrow key, to select RAID 5 for parity, and then enter. And then basically your stripe size for RAID 5, it tells you to follow your typical value. So the stripe size or the strip size for RAID 5, excuse me, is 120. No, for RAID 5 is 64K. So you want to change that to 64K. We're doing a 1.6 tera, which is all 2 drives. All right, enter. We're going to use all of that. So it will automatically read the size of the drives. And hopefully you paid attention to what the drive sizes were in the BIOS configuration. So this is an indication of all the drives. So we don't need to change that. So we hit enter. And then basically you're at the point now where you want to create the volume, and basically press enter to create volume. So warning, all data on the selected disk will be lost. Basically, it'll do a formatting, et cetera, for you. So do you want to create this volume? Yes. So as you see, it'll show you what the RAID 5 is now. You get a volume name, the parity. Each of the drives are 808 gigs. So now you have a full RAID 5 array for your system. So navigate down to 6 and exit, and it will take you through the non-OS boot screen. Any questions?
Wait, when would you, this is Carol,
Okay.
when would you know how to do the formatting in the BIOS like that versus going to the device manager?
Well, in this, as it is showing you in this scenario, you don't have an OS. So basically, the only thing that you can do here, if you boot to a system without an operating system, you will receive a screen that looks like this.
All right.
So that means you don't have an OS. So that means you don't have access to the disk management utility, the disk management GUI that's part of the OS. So,
Okay.
so the only place you can go here is to run a diagnostic or go into the BIOS.
Got
And
it.
here you want to check to see that your drives are recognized anyway before you build the RAID. And then after you build the RAID, then you add the OS or whatever else you want to do with it. But generally, that would be your first approach. And this is before you install the operating system anyway. You're just setting up the drives to perform at their highest level, et cetera. Does that make sense?
Okay, it does. So from the black screen, how did you get back to that BIOS?
So you just hit the delete key.
Okay. Got it.
All right.
Yeah. Great.
And that's a pretty good simulation. This is essentially what you would see on a system that you just pulled off and you just installed hard drives, and you're getting ready to set it up so you can install the operating system, et cetera. So at this point, you would stick in a CD or DVD or a thumb drive and install away. It'll boot from that thumb drive, et cetera.
I have a question regarding the BIOS. Would all BIOS look similar on the Windows?
Yes, this is very standard for an x86 system. Yeah, very standard. Of course, getting to the BIOS may be a little bit different depending on your keystrokes. And if you're on a Mac, no, Macs you don't necessarily access the BIOS. You just access the system configuration on the front end. Macs are a lot different. This is only true in Windows systems, x86 systems. Other questions? Let's go ahead and score the lab. You're right. Now you'll probably see that type of configuration over most others. If you have multiple drives and you want to set up a RAID, typically on your regular systems, you're not going to set up a RAID. There's really no need to. You're just going to run your regular drive. Unless you're running an SSD and you want to go in and reconfigure it, but you have to be very careful. Once you pull that system off the shelf at Best Buy or the computer store, the disk management is already set up. The only reason why you would want to reconfigure that if you want to reinstall the OS, which means that you haven't put anything on it yet, and you're planning to reinstall the operating system. But generally, you're not tinkering with the RAID on regular systems. This would only be in a computer setup scenario where someone is setting up a higher end type of computer, and they're asking whether it's a server or a high-end PC, they're asking you to do some more things with additional hard drives. All right, good. So far, so good. All right, so we've done our RAID labs. Let's see. All right, so we have another video. Our next video for our next act, 551, which is partitions, volumes, and file systems. Maybe you should have watched this before I asked you about NTFS. All right. So we're going to go ahead and continue to go through the remainder of the labs and the videos, well, this video and 2 more labs, and then we'll take a break, and then we'll go into our packet tracer hour, yay, or half hour, or whatever. All right. Are we doing okay? Hanging in there? Glad you're in the class?
Yes, we're good.
All right. All right. Let's start our video on partitions, volumes, and file systems.
Most long-term storage in a computer is done on a hard disk. In this lesson, we'll look at how to prepare a new hard disk drive so that you can organize and save data to it. When we add a new hard disk to a computer, the computer cannot use that hard disk for saving data until it's prepared so that the operating system knows how to identify and save files to the hard disk drive. The first step in preparing the hard disk drive is to create a partition on the hard disk. A partition is a logical division of the hard disk drive. A portion of the hard disk is carved out and prepared to save data. You can create a partition that takes up the entire hard disk, or you can create multiple partitions on a single hard disk. For instance, I can divide this hard disk into 2 partitions. Any space not assigned to a partition is labeled as unallocated space. When you purchase a new hard drive, the entire hard drive is generally unallocated. Before you can use a partition for saving data, you need to create a volume. A volume is a single storage space within a computer. A volume can cover that entire partition, or we can create a volume that spans multiple partitions. This is useful if I've defined a partition to use this much of the hard drive with some unallocated space. I could add space to that volume by creating a new partition and assigning that partition to the volume. I could also take another hard drive and create a partition on that second hard drive and assign that space to the volume as well. Because partitions and volumes are logical structures, I can create a storage space that uses multiple chunks on a single drive or multiple chunks on several drives. When we define a volume, the operating system assigns a drive letter to the volume. For instance, the volume could be assigned the C drive or the D label. This helps us keep track of different volumes that have been assigned in the operating system. The last step you need to perform is formatting. Formatting prepares the disk area with the rules and the specifications for how data is saved. The file system identifies how files are located on a drive and identifies any additional features that are available for storing and managing your files. Windows supports 2 different formats for hard disks, either the FAT32 file system or the NTFS file system. In most cases, Microsoft recommends that you choose NTFS for the system of your hard drives. NTFS has some advantages over the FAT32 file system. For instance, it supports larger disk sizes, larger file sizes, disk compression, encryption, disk quotas, and folder and file permissions. And in some cases, there is a performance benefit from using NTFS over FAT32. Within a volume, we can create logical objects called a directory or a folder. A directory is nothing more than a container for organizing files in your storage space. After creating a directory, we can create or add files to go in that directory. It's important to note that when you create a directory, you're not actually moving files from one location to another. Instead, you're creating a logical entry to which all files are associated. Directories take up very little space on the hard drive. They're basically a directory entry that has files associated to it. A file contains the actual data created by an application. For example, your file might be a Word document, graphic, or audio file. Files occupy space on the hard disk, and they have a start and an end point. Most file systems are able to store files as separate chunks, so you could have 2 or more chunks on the hard drive that make up a single file. It's the job of the file system to describe the format of how files are identified on the disk, where a file starts and stops, and how file chunks are linked or referenced together, so that the entire file can be pulled together from different portions of the hard disk. So let's review what we've talked about. In this lesson, we talked about how to prepare a new hard drive so that we can store and save our data. To do this, we create partitions, we create volumes, and last, we format the disk space.
All right. Lots of information, good information about file systems and partitions. All right, so let's go right into our lab. 563 and 565. Okay, the first lab is create volumes. Okay, so you're the IT administrator for a small corporation, corporate network. The computer in Office One needs additional hard drive space. You have 2 hard drives available. You need to install the hard drives and create volumes on those hard drives so that they can be used to store data. Let me check this. Oh. All right. All right, so we want to create a volume on disk 1 with the following properties. 300,000 meg or 3 tera, drive letter E, NTFS, volume label data. And then we want to create a second volume using the remaining disk space on disk 1 and all the space on disk 2 as follows. Drive letter S, file system NTFS, and then a volume label ARC. So we're going to do some fun things with our 2 drives. All right. So let's start the lab. All right. Okay, so let's see what we have here. We have the hard drives already in, or do we have to install them? So, nope, we need to install 2 SATA hard drives in the computer. We're adding space, so let's just go and do a shutdown. All right. And go into our motherboard. And this motherboard has our drive bays here as far as our hard drives. That's a little tricky, but just remember that. So I'm going to go ahead and install 2 hard drives. 1 and 2. And yes, we have to do all the SATA cables. And we're already on a motherboard right there. All right. So first hard drive. And onto our motherboard. All right. Second cable. Second hard drive and motherboard. All right, and then the power. That one's used, this one isn't. Power to drive 1. Power to drive 2. All right. So they're installed. So we want to initialize both drives using the NVR, partition style, etc. So now we got the drives in. Let's go ahead and start the system back up. All right. So remember to get to our disk management, right click on the window, and it does recognize that there's 2 drives. We want to initialize them with NVR. Okay. All right, so here are additional drives. Each are basically 600 gigs, 585 gigs. All right, so on the first drive, we want to create a volume E of only basically 300 gigs, excuse me. So you right click. Now we're just going to create a simple volume, right? Because span, and stripe, and mirrored, and RAID 5, they all involve more than one disk. So a simple volume is what we want to create for this particular disk. So this will launch the simple volume. This is not a RAID. This is just a simple volume for that disk. So we launch the wizard. Next, it's giving us 600,000 megs of space with an 8 meg disk drive minimum. We want to decrease that to 300,000, right? According to our instructions. We want to label this drive letter E. All right. NTFS, we want to name the volume data. Right? Perform quick format. Next, and finish. So what happens, we get that 300 gigs space, and we have an additional 300 gigs of space remaining. So, and then we have a second drive. And so we want to create a second volume using the remaining space of disk 1 and all of the space in disk 2. So this is a little bit different than a striped or mirrored, because you can't mirror the drives. You can't stripe them because they're not, well, we could stripe it, but in this case, we don't want to create a RAID. We want to create just an extended, or, you know, what's known as a spanned volume. So you right click on that additional space, select span volume. This is basically a volume that you can use to create volumes across disk with disproportionate amounts, or a selected amount. And it works like a mirrored or a span, but you can create this volume with a scenario such as this one. So we click next, and we know that we have 300 gigs on this one and 600 on this 2. We want to use both, right? We get our 900 gigs, so you just highlight, select, and add. And then, so then you just continue in the wizard just like before. You want into NTFS, 5-letter S, and R is the volume. 5-letter S. NTFS, volume is part. Next, and some more summary, and finish. And you see our nice little purple here. We have part across parts of disk 1 and all of disk 2. All right. Any questions about that? And you will see that a lot. You actually will see that a lot. in personal computers because you're just creating a different volume across drives, and it is actually a high level of performance when you do it this way. All right, so this is score.
Wait, so why did you pick the spanned volume? Is because of the instructions?
No, usually you'll do, okay, you don't, generally, you don't want to choose a mirrored. Mirrored is essentially that, it's a mirrored drive. And striped is usually more, it's a RAID 0, it's a basic, and it's usually the drives of the same size, because if you begin choosing drives that are different size like this, you get less performance technically. And you will see that in the study. It may or may not say that specifically, but span, you usually want to use a span volume along with a simple volume to maintain that higher level of performance.
So the speed.
Yeah. If you choose any of the others, well, you can't choose mirrored. You really can't choose stripe too. Stripe will give you some issues because that's a RAID 0. RAID 0 is designed specifically for fault tolerance. So there's all other issues that will come into play if you try to choose stripe. You can, but it won't work the way you think it should work. Span will actually work the way you want it to work.
Okay,
Okay.
thank you.
Faris, you didn't change anything on the second one, right? You just put the letter S and R.
Right. So you just selected the whole drive for
Yeah.
that second volume.
Okay, you didn't change the numbers. Okay, thank you.
No, you don't change it because we want to use the whole drive.
Okay.
The remaining part of disk 1 and then all of the disk space on disk 2.
Okay.
And generally, that's what you want to do. If you start partitioning your drives too much, then you're creating more. Yeah, it's like dividing. You know, you have too many places to write things, and your motherboard will not like that. So, other questions?
That's all. Thank you.
All right. All right, in our last lab for this evening, oops, I don't want to start the lab again.
Five, six, five.
565, right?
Yes.
Yep. And 565, yeah, this one should be pretty straightforward as long as you follow the instructions. So what we're going to do is that we're going to format. I think we're formatting a thumb drive or flash drive. Okay, so you're the IT admin for a small corporate network. You're working on the computer in Office 1. In this lab, your task is to complete the following. Format the flash drive with a FAT32. So what does that mean? What is FAT32? Does anyone know that? Well, we have NTFS, and now we have FAT32. What's that?
Yeah, it's the pot.
What's that?
Not sure, but isn't that what Macs use most?
Yes and no. But what is that?
That's the style of format, right? For the drive?
It's a style of formatting. So what does FAT32 mean? It is a style. NTFS was the new technology style. FAT32, what is that? Who can give me an answer?
FAT32 is 32-bit file allocated table.
32-bit file allocated table, which is really kind of outdated, but it is the primary file allocation scenario for Mac. But there's a FAT30, there's a different style, even a FAT64 sort of. Hasn't really been labeled yet. But if you want to go back to the way things were formatted before the NTFS, NTFS was primarily the 90s. And it's still the standard for today, but FAT32, it's still a good format, but it's primarily for smaller disks. When you get into larger space disk, etc., for efficiency, it's usually more of the NTFS. So anyway, we're going to format the flash drive with FAT32 using quick format. We want to use the convert command, and yeah, I'm wondering how many of you know what that means? Convert, this will be interesting. So we're going to use the convert command to convert the G drive, which is a different drive, to use NTFS instead of FAT32 without destroying the existing data. And you'll see this all the time. And the convert command is the simplest way to do it. There's other methods. And there's even some GUIs out there that you can do conversion without destroying the data. But convert is the most reliable on a Windows system. But there's really only one way to do that, and we're going to do that in this lab. And I'm going to see if anyone can figure out how to do that once we get to that point. So let's start our lab. All right. So let's just take a look at our desktop first. I just want to see what we have in here. I'm just looking at our PC. We do have a C. Well, we just did this. So this is our C, D, and E in our Explorer. And if we go to our disk management, yeah, this is what we completed. This is a little different, but anyway, that's what we're doing here. All right. So let's go back to our bench. And we have a thumb drive here. Let's just take this and plug it into one of the USB ports in the front here. And if we go, we see that now this is the G drive, and we're going to format it anyway. So let's go to our disk management. And we do have a flash drive in here. You see that? So if you right click on the flash drive, right click, there's a format selection. If you select that, we're actually going to format the drive. We're going to format it FAT32. Keep that as default. We want to do a quick format according to our instructions, and OK. And basically you get the warning that says, if you run this format, it's going to erase everything that's on the drive and it'll be nice and clean. So you click OK, it takes a few seconds. And the thing you want to make sure in here is a basic format, FAT32, it's healthy, and it's 4 gigs, and we have 100%. So that flash drive has now been formatted. Now, to convert, so how do you do a convert? You can't obviously
drive.
Say that again. Our D drive is on.
Yes.
So
drive.
we convert it here.
Mm-hmm.
Someone says yes.
Yes.
How do we
try going to the search box? You type CMD.
Yeah, the command prompt or DOS prompt.
Command prompt, yeah.
Right? Because this we're running a convert, and this is where, and we want to run it from our administrator. All right, so I'm pretty sure we can help here in our simulator. So who knows the command we want to convert? What drive do we want to convert?
D.
Convert D.
All right, now what?
Convert space D colon space. What kind of, is that forward slash or back?
Slash.
Yeah. Forward slash.
Okay.
And then
colon
FS.
Enter.
FS, NTFS,
So FS is file system.
file system,
And then
yeah, NTFS.
Does that look right?
no space, the NTF.
FS,
No space?
FS
No
colon,
space, that one. And then
FS
the
colon,
colon is
and then
in
NTFS.
between FS, the
Uh,
colon.
Nope, that's not right. So what's not right here?
Convert,
I will type it.
convert, space,
Convert,
D,
Yeah.
colon, space, FS, colon, NTFS,
is that right?
enter.
Nope.
No.
What are we missing here?
Like this. Convert.
Come on, you're close.
Semicolon slash FS.
What's wrong with that command line?
Enter. That's the command.
That's the command, so that should work?
Yeah. Mhm.
Doesn't seem to be working. I'm getting invalid parameter in TFS.
No space.
No space.
No space.
But the D colon, then space slash. Wait.
D colon, then space. That's
Yeah.
what I have.
I got it.
No, that says invalid drive specification.
It should be FS and then semicolon. Oh no, not semicolon.
FS and then a colon?
No, it's not semi. Colon.
You're all taking me on a wild goose.
No.
No?
No, that one. Take off that colon in between the slash and FS. Slash FS colon.
Colon, okay.
Mm-hmm.
And then TFS.
Yes, no space between the colon and the NTFS.
All right. There you go. Good job.
Data.
Took you a long time to do. So you can enter our current volume label for drive D here.
Data.
And what's our current label for drive D? It has to match the one that's on there now. Is it data?
Yeah.
Yeah? What is it? You can
Data.
always check. You can always go open up your, oops, hold on. If you're not sure.
Data.
Go to
Data.
management. You see that drive D, the volume is data. So back to our, and boom. So once everything is entered correctly, you see that the conversion, it checks the files, make sure it's not changing any files or folders. It changes it from FAT32 to NTFS. And if you go back into this management, you notice that it's now data NTFS, and it was FAT32 before. And the flash drive is still FAT32, right? And it has it up here too. Good job. Did you guys Google that, or did you know it? Are you fast Googlers, or how'd you figure that out, Melba? And who was that, James? Google, yeah. All right, good job.
I ask.
Good job. Google, yeah, you can Google that. It's a very common, convert is a very useful command. There's a bunch of commands in DOS that are useful. All right. So good job. Way to go. All right. All right, so we finished our labs and videos for the evening. Let's take a 20-minute break. We will begin again at 7:30 with our packet tracer download and install scenario. All right, does that sound good?
Yep.
Okay, see you all at 7:30.
Well, you done me and you bet I felt it. I tried to beat you, but you're so hot that I melted. I fell right through the cracks. Now I'm trying to get back. Before the cool done run out, I'll be giving it my best. This and nothing's gonna stop me but divine intervention. I reckon it's again my turn to win some or learn some, but I won't hesitate no more, no more. It cannot wait. I'm yours. Open up your mind and see like me. Open up your plans and damn, you're free. I look into your heart and you'll find love, 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 love. Listen to the music of the moment, people dance and sing. We're just one big family, and it's our God-forsaken right to be loved, love, 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 love. So I won't hesitate no more, no more. It cannot wait. I'm sure there's no need to complicate. Our time is short. This is our fate. I'm yours. Do you want to come on? Scooch on over closer, dear. And I will nibble your ear. So the bubble won't I've been spending way too long checking my tongue in the mirror and bending over backwards just to try to see it clearer. But my breath fogged up the glass, and so I drew a new face and I laughed. I guess what I've been saying is there ain't no better reason to rid yourself of vanities and
Something recording. Yes, I forgot to record it. All right, well, that's all right. I will record it again on Wednesday. I had paused the recording, but now I'm recording. So I'll go through the installation again because I know there's some students that will want to see all of that that aren't here in class. So go ahead and enter your email and then your password. Sorry about that. I will record it again, and this should take you to your main working platform for Packet Tracer. And this is where I want you all to end up, if you can, because we are going to run just a couple very basic things in here on Wednesday to get us started on networking. Any questions? Yes, I was not recording. I know Danielle's probably been screaming that for 20 minutes. We're not recording. I'll go over it. I will go over it again on Wednesday. So once you get to the main working platform for Packet Tracer, you can take a look. There's tutorials. If you click on the help on the top menu items, there are a bunch of tutorials, and they generally will run in your browser. So just select the browser, and a lot of these we will actually go through just to get you started. As a matter of fact, what I'm probably going to assign you for the homework on Wednesday, along with your other homework, is just going through getting started in the tutorials in Packet Tracer. Just this way, I know that you have it installed, and because it's really the only place that you can access these tutorials. So I will probably have you just go through this so you can see some of the things, and then maybe talk also Wednesday. I'll probably talk about the logical workspace, and some of these are part of what you'll see in our networking environment. But a lot of what we will accomplish in Packet Tracer will definitely help you to envision networking and the network, how networks work, et cetera, et cetera. So definitely, this is another very useful part of Cisco that you can bookmark. So let me close some of these tabs here. But once again, the way you get to the tutorials in Packet Tracer, under the help menu item, there's a tutorials, and basically you choose the browser that it opens in, and it'll open up in the browser for you.
Nice.
All right. So how are we doing? Did everyone get to the working environment okay? It's a very, very useful tool. So it may seem a little bit complex now, but believe me, it'll become very, very useful for you doing the networking, especially when we get into the Network Pro. A lot of that you can just take it upon yourself to build these basic networks, so you can see things actually happening as far as communication. So yes.
Wait, on the tutorial part, I see that there's close to, I'm just going down to like 15 chapters, I guess.
On which part now?
Oh, that's the online tutorial?
Yes.
For the Packet Tracer?
Right.
Would you recommend, taking a look at all of those as we progress, or is it, just the top?
Okay, I'm going to try and map most of them.
Okay.
Don't take a look. You don't really need to take a look at all of them. Some of them will map directly. Some of them you see that will be completely applicable to what we're learning. But all of it is useful. All of it is good to know, but it will be overwhelming quite quickly. I'll just warn you of that. So be very careful, especially if you're brand new to networking. We want to get the basics down, which is why we start networking in PC Pro. We talk about basic computer networking, network cards, and all of that before we get into complex IP addressing, et cetera. So yes, it can become a little overwhelming quite quickly.
Okay, thank you.
But those first getting started, that basically introduces you to the environment. And once we're into it, a couple of weeks, I'm going to assume that you all know it fairly well. So I'll just go through. I'll just tell you, okay, we need to set this up, this many routers and this many PCs, and then I'll expect that you all have it set up as almost as quickly as I can set it up, although I'm not really that fast. But I've used Packet Tracer for many years. So, all right, any other questions?
It seems that's kind of hard because it's my first time seeing this kind.
Yeah, well, it may seem a little overwhelming in the beginning, but once you start working in Packet Tracer, I mean, you can build one of the most complex networks um, that you can ever see, you can simulate that in Packet Tracer, believe it or not. So you can simulate things like cloud services, any type of corporate infrastructure, from email services to web services. All that can be simulated in Packet Tracer as far as the networking. So it's very, very useful, and yes, it can become very complex very quickly. So kind of prepare yourself, but don't, we ease you into it. We go into networking basics before you get into the Network Pro. It'll definitely help you for the Network Pro certification and the Network Plus certification. All right. But don't be overwhelmed with it now. You're just opening the door. So, so kind of put it on the back burner, concentrate on finishing the PC side of it, and then you'll be inundated with the networking here pretty quick. But it is one of the most important aspects of IT.
Oh, by the way, Dwight, like, for example, I passed the first one, the certification. And then is there a job that's corresponds to that one, or there's not yet?
So you passed the PC Pro cert already?
Yeah. Is there a job for that, or you need
really.
to finish the other certifications?
Yeah, definitely you need the PC Pro, Network Pro, and then that's help desk or basic computer services. PC Pro, now how much do you know about networking, James?
None, actually.
Okay. So no, I would not, I would wait until you have the network certification at the very least, the Network Pro.
Network?
Then you can position yourself for any of those basic entry-level IT positions.
Yeah, because just right now I'm having difficulty on this. What more if you're gonna proceed on the other subjects? Oh.
Well, just remember, IT is a lot of subjects, and you'll learn all of it in this class. But you have to figure out a way to find a comfort in what you know and possess the ability to draw upon or retain or remember, just some of the things that you have some idea, like hard drive setup. I mean, you've done enough of those, and right now you've just done some partitioning and volumes and RAID. Will you see that in the industry? Probably not, especially not an entry level. But you may run across, if you're a part of a help desk, you may run across an issue where someone's computer doesn't boot up, and basically you troubleshoot it down to the hard drive, and you'll be able to help them to either reposition or reconfigure their hard drive, things like that.
I wish there's a job after just finishing that.
Yes.
The first one.
Well, yes, there is. And the thing with this, even with the rudimentary knowledge that you have now, you can probably, you don't really have networking knowledge, which is a big part of it, but you can probably get into the help desk position with your PC knowledge, because a lot of it is about just, most people really need, basic help setting up their PCs, understanding what drives are what, especially in the new age of computers now. They're pretty modular, relatively easy to convey to individuals what they need to know.
But if you're looking like getting a higher pay, you might as well finish the program.
Yeah, the higher pay comes with more knowledge and you're to convince that employer that you're wanting to learn. So that's more more appropriate as to where you go from here.
Yeah.
Other questions?
Done. Thank you.
Yep. Ralph, how you doing, sir?
Well, I already knocked out all the Packet Pro. I was actually working on the homework. I already finished the first homework assignment, and I was on the second one, and I keep failing the lab. I'm like trying to go. I've already done it like 4 times.
In the homework lab?
Yeah, so I'm just trying to figure out why I keep failing it.
All right, well,
Like,
you can always share your screen, and we have time if you want us all to review. This will help your classmates.
I mean, if I guess we could do it together if you want to do it together.
What number?
What number?
Hang on.
So if you want to
584.
Yeah, if you want to share your screen and show us what you're doing, we will definitely all chime in. All right.
So it's 584. This is the second homework assignment, I believe. So we're making a storage pool with our disk.
Right.
So if I remember correctly, you got to go to the BIOS. You go to SAT op. You got to turn RAID on. Apply. Exit. And then get ready to hit Control I.
All right.
Create RAID volume. And then it says to label it extra space. So
All right.
extra space. And then it says to set it to parity. Select disk. So it has to be at least 3 disks. So space, space, space.
All right.
Enter. And then you want to tab. I got stuck on that for a little bit. You want to tab, right, to get to the next box.
All right.
And then for RAID 5, we got to set 64.
Yep.
And then the default's the max volume.
Yep.
And then create volume. And
Yes.
Y. And then we go to exit.
What?
Yes.
Another one.
Y is yes.
Oh.
And then want to format our disk, right? Am I right? Like, am I heading in the right direction?
So I did the same thing you did, Ralph, and it hated me. So when I did the score lab, it does give you like kind of like what you want to do.
Yeah, all the steps.
Any of that.
It doesn't hate you. It just tells you you're wrong.
Yeah, so it hates me. So what it actually says to do is type in the bottom, like the search part, to type in storage and do the manage storage spaces.
Yeah. Yes.
Oh.
Create a new pool from that.
This is where you create a pool.
Yeah. So yours is actually just the extra space one already. And then I think you can just, that's where you would assign.
This is where you, yep.
Oh.
5 letters, yep. This is a little bit different than RAID, but it's an additional, there you go.
Oh.
Then you'd have to change the size capacity. But I think because of the way you did it first, I don't know if it's actually going to give you, like it'll give you 100%. Does that make sense?
Yes.
Yeah.
Because when I did this part here, if you do it straight from the storage, then it should be like 2.3 terabytes for the maximum size.
Yes. And that's all of the drives.
Got it.
Because, yeah, I started doing it the way you did it, too. And I was like, I don't understand. Why does it keep hating me? So
doesn't hate you.
And I read the steps because I didn't know what else to do.
So it's not going to allow you to.
I got to start over.
Yeah. And basically you have to start from the storage devices because you won't be able to utilize that max size of 2.3 tera the way that you're building it.
Well, thank you, Stacy. I was doing it like 3 times. So I was like, what the heck's going on here?
Well, that would be the normal way that you would want to do it, but you see that these drives are already set. You're just creating a storage pool. So you want to boot right into Windows and then go to storage devices.
I was doing it like we just popped them in, huh?
Right.
Oh.
Right. See, that was not the case. So yeah.
And to be fair, it's not like we went over that part before.
No, we did not. But that is on one of the study sheets.
It's not in the video though.
It's not in the video, no.
See, so they trick you and they really want you to look at everything before you do the homework.
Well, Stacy, that's the whole purpose.
I'm a teacher. We always, what's the fastest shortcut?
Oh, well, yeah, all right. Understood. But see, you're adult learners, so we task you to understand that you probably have to do a little bit more than what you're told to accomplish the task.
Done.
There you go.
There you go.
There you go.
Well, see, the key term here is pool and storage spaces. That's a little bit different than RAID. So this is something we're using the drives that have already been set up to create a pool of the maximum space. So yes, it does require a little bit more research than just, I didn't see that in the video.
Yeah, I kept thinking like I missed a box or I typed in something wrong. So I did it like 4 times, but I didn't even think about reading like the instructions like after you fail, like what Stacy was saying. So yeah. I guess that would have saved me a lot of time.
And remember that's a good, all of you remember that if you fail, definitely read the recap, and it'll give you exactly what the lab is looking for as far as the processes. If you don't want to read like the additional information, the study sheets, or all of the labs have additional information that you can take a look at. Yes, everyone should thank Stacy. You probably would have spent many hours on that lab.
But pretty much the way we went over it in class is if you were throwing them in from scratch, right? Building it. And the way we're doing it now is it's already built. It's already done.
With that lab.
Got it.
You're just creating a pool of the volumes and partitions that are already built. So. Exactly. See, there you learned something, right? Any other questions? Any other labs, homework labs we can go over? Did you all successfully install Packet Tracer? Or are you going to do that this week? Or at least before Wednesday? Yes?
Yes.
All right. That's everyone, right?
No.
What's that, Melba?
I tried to install it, but I can't open. I don't know why.
You can't open. I mean, is the login?
Yeah.
Is the login failing?
Yeah.
You sure you have the correct credentials that you set up in the Cisco Net Academy?
Okay. Right again.
We went through the steps where you create your profile.
Yeah, I download it. I accept the license. Install.
And that's kind of the issue. If you forgot your credentials, you can run the forgot password just like anything else, but it will send you a password reset to your email address. And then you basically have to reset your password and try the login again. You do have to log in. This is a protected platform, so you do have to log in every time. Well, not every time. It will cache your login, but you do have to log in periodically to the Packet Tracer environment.
Because I have installed Tracker. Place here 7:30.
You want to share your screen, Melba? We're all here to help.
Done. So I want to